Okay, welcome to 10.3.1. So for this one, we are imagining that we did a brain training game. So I would first give you a bunch of words and you would read them over and over and over again. And then you would tell me, you would see how many you could remember. Then I would give you a bunch of words and a strategy, and you would use the strategy to try to memorize them. And then you would tell me how many you remember. Then you would find the difference. So you would do A minus B. And then we would create a dot plot that would look something like this, where on the bottom, this is our difference. A minus B in words remembered. So the dot plot, when we're looking at it here, suggests, well, A minus B, most of these are in the positive range. So that's going to suggest that A, you memorized more words. So since the differences are mostly positive, it suggests A is better. But are we sure? No. The mean of our sampling distribution is 1.5. So on average, we remembered 1.5 more words with strategy A. And our standard deviation of our sampling distribution is 2.1. All right, now, like usual, we're going to see if there's a more precise way to do that. So we're going to construct a 95% confidence interval for the true mean difference in words remembered. So the parameter that we want to find, the true mean difference. So the statistic that we're going to be using is the sampling distribution difference that we calculated earlier. Our confidence level, 95%. So this is a means. So we're going to use a t-test. This is a one sample t-interval for the mean difference. Our conditions. Random. Well, I'm telling you that I would have handed things out at random. Our 10% condition. These are these words that you're using. These people that we would be training would be less than 1/10. All people and words. And then looking at our chart, we're not greater than 30 here. We're not greater than 30, but we can say that there's no strong skew or outliers. Okay, now our general formula for any interval is our point estimate plus or minus our margin of error. Our specific formula, well, our point estimate is the mean difference plus or minus t star times our standard deviation of our sample over the square root of n. So our mean difference was 1.5. So 1.5 plus or minus, we have to find our t star. To find our t star, we need our degrees of freedom. N is 13, so our degrees of freedom is 12. Then I'm going to go to my table. So I've got 12 degrees of freedom, and I'm at 95% confidence. Okay, where am I? 2.179. 1.5 plus or minus 2.179. Our standard deviation was 2.1 over the square root of 13. Pull up my calculator. Okay, so I went and got my calculator, and 2.179 times 2.1 divided by root 13 gives me 0.176. So my answer is, 1.5 minus 0.176. That the true mean is between 1.324 and 1.676. So we are 95% sure the true mean, the true difference in means between A and B is, the true difference in means is between 1.324 and 1.676 words. So do we have convincing evidence that there is a difference in the average words? Yes. Both bounds, lower and upper, are positive, so the true mean, or the true mean difference, must have A, remembering more words. And so then we're on to our big ideas. So the first thing we had to do, let's see if I can put this on here better. Okay. The first thing we had to do was describe our distribution. Where we had no difference. And if this side, the positive side, was bigger, this means that the first option was larger. If this side was bigger, that means the second option is larger. And our true mean that we're looking for is the mean of the differences. What we looked at here, our statistics were the sample mean difference and the sample standard deviation of the differences. Then we did a one sample, because we only had one sample, t interval for our mean difference. And the formula we used was our point estimate plus or minus t times the standard deviation of the differences over the square root of n. And that's that.